getting to circuits, semiconductors, power electronics. And you're not wrong, it's all very easy. But that's just the beginning of the story in our department. A lot of things and a lot of other things as well. So electrical engineering really means, or what we are doing in our department, is we are taking control of electrons, photons, information, intelligence, and...
Professor, can I ask you to give this mic?
Yeah, sure.
How do I do that? Audible? So as I was saying, we take electrons, photons, intelligence, information, and we're trying to manipulate things around us to have systems work and do different tasks for us. Okay? So I'm not quite sure what your mind electrical engineering is, but it covers all of these aspects. So what would you as students be doing in our department? Well, it depends. You might end up working in AI and ML. You might be designing circuits. You might be working on motors. You might be working in getting clean energy solutions. You might be even working on improving medical technologies, imaging, communication. It's a vast range of topics. So for the students here today, you're really sitting at a point where you're going to start this journey to becoming an engineer who can do one of these things, or maybe a combination of those things. Okay? Now, what is it that you're going to do in the department? Well, you'll see. Let's take the example of a smartphone. We all have a smartphone. Maybe we even have more than one smartphone, right? There's a whole ton of electrical engineering in this one device. And I'm only taking this device as an example. So I myself work in the area of photonics. I'm interested in the cameras in this phone, the sensors in this phone. Then, of course, there's the image processing that goes for every image we take with the cameras of this phone. There are people who are interested in working in the design of the circuits, the chips. There's the display, the materials of the display. There's all the coding and algorithms that go into running every app and every system on this phone, right? So that's just one example. But this phone, if it does all that and you design it to do all that, but it's unable to communicate with the world, what's the point? So you also need to make sure that this phone can communicate with the world. And for communication, well, maybe your phone is connecting to a base station. There's all the hardware and algorithms and coding in the base station. That base station may be communicating to a satellite link, maybe linking to a fiber optic link, maybe going to a network or a data center, maybe going as a fiber link to a home or a building. In our department, we have people working in every segment of this. And as I keep saying, this is just one example. There are many different examples. So if we look at, and actually I don't want to run the video, so let me, is there a way to stop that video? Yeah, okay, good. So these are the broad areas that are, we have faculty working in our department. We have 7 main areas. And when you come in as a student, you're going to be taking courses in all of these areas. And I just want to give you a highlight of some of the key research work. Why? Because these are the people who are going to be teaching you. We have experts who are doing state-of-the-art work in all of these areas. So for example, the first indigenous 5G network phone call, that means the network was end-to-end built within the country and a phone call was made on a commercial 5G phone. That happened in this institute, okay? We have a center where they design OLEDs, and we have the indigenous state-of-the-art active matrix display we can design, fabricate within our department again. Okay? Again, completely indigenous. And we also have people, I mentioned the word medical technology, so we also have a very extensive research going on in healthcare technologies, and this is a project from some years ago where these two trucks are designed so they can drive into some rural area and then cataract surgeries can be held. So all the instrumentation that was developed for this happened again within the department. Okay? And this was in conjunction with doctors, and you can see so many surgeries have been held so far. Now, why am I talking to you about these topics? Maybe as students, you think I'm just coming in to learn some things. Again, I'm stressing that the people who are doing this research, they're the ones who are going to be teaching you and taking you through your courses. Okay, so that's just some of the examples. There's a lot more work, but let me get now to the curriculum. So you are mostly going to be here for the 4-year BTech program. This is how the courses are split across the 4 years. The first year is foundational courses. In fact, many students from other branches will have the same maths, physics, programming courses. In particular, our department also has some basic courses in signals and circuits. I will use the term core and elective. Core courses are courses that you have to do in order to complete your degree. And elective means there is a choice of courses. You can pick whichever you want out of that choice, and those credits together will help you complete your degree. In your second year, you start doing a lot more of the core courses, but within the department, those courses will be in the areas of communication, devices, electromagnetics, and machines. And in the third year, the first semester of the third year, you complete your core courses. Now, you still have 1.5 years left. What are you doing in that time? At IIT Madras, we're giving you the flexibility to choose elective courses so that you can find out or explore or go deeper into areas of interest to you. So initially, you can choose from a set of stream electives. That means you have choice, but the choice is within department courses. And then you also, in that year, you have more humanities courses. And if you have finished your core courses, you can actually take a summer internship, and you can even make that a full 6-month internship if you've finished your core courses, which means you can go and work in a company or at another academic institute for a full 6 months and gain experience of a different kind. In the final year, you finish up with other electives, and this unallotted credit means you can choose courses from any department. So if you have interest in some other subjects which are not covered in electrical, you have 6 courses there that you can pick to broaden your knowledge. So you can see there's a lot of flexibility in the system. Coming into electrical, although there is so much diversity within electrical itself, you could spend your 4 years exploring electrical, but you're not restricted to doing that. There's a lot that you can explore in the institute itself. Okay, so as this just kind of highlights some of what I already said, you have 6 courses you can take from unallotted credits. You could take them from any of these areas within the department, but you can also you can also take them from other departments. And if you find that, the exciting research work I showed you at the beginning, if that has caught your interest, you can also start exploring mini research projects. You have that option. And you could, if your grades are good, you could even stay longer and get a second degree, an MTech degree. So that's the dual degree program. After 5 years, you would graduate with a BTech and an MTech. You have 2 options there. You can either get the dual degree from electrical engineering, which means both your degrees are from electrical engineering, or you could get a BTech from our department, and you could get an interdisciplinary dual degree. So your MTech could be from another department. Okay, so again, you have this option to explore and look at other subjects and topics. Okay, of course, your goal probably coming here is to help you get a job, and these are doing an internship is a step to that. So these are the core areas where our students get internships. Of course, there are internships in other areas as well, but these are where most of our students will go. And you can see there's opportunities both in core engineering, in engineering sectors, but there's also opportunities in finance, consulting, and analytics. And you also have the chance to work in startups or go for research.
Mostly.
Okay. So it's not only work in the department. You can use the skills that you've learned and try out for different competitive teams. So currently you can see that we have some really big teams that are taking part in big competitions, either national competitions or international competitions. The teams, though I've listed them here, please note these are interdisciplinary teams. You may be even up to 30, 40 students, and those students will be a mix from a variety of departments. It will not only be our department, but you can be sure that you need electrical engineers in these teams. So there's definitely opportunity for you to be part of these teams, or maybe even join up with a new competition. We have other activities. And we also have a center for innovation, and if you have an idea, you can go and try it out. It's called C5, and it supports student-led projects, prototyping, and so on. Where do our alumni go? Of course, we have had a lot of alumni. They go wherever they need to, and they excel wherever they go. Here's just a few examples from some companies you might have heard of. So Perplexity AI, Zoho, NVIDIA, and then we even have people who leave IIT, go into management, and so we have someone who started and is in charge of that cosmetics company. Okay, so you can see the data from the past. Where have our students gone? What kind of field they've gone in? So this is a kind of pie chart showing you the areas that students have got jobs in, or what they've done after finishing their BTech program. So some fraction go for higher studies, others go into engineering, software analytics, finance, so they take up a job there. Some do now, we're seeing a larger number having their own startups, and a few also go in for civil services.
How much is software analytics, how much the core?
Core will be a smaller number of that, yeah. Okay, I think that was my last slide. I have with me my colleague, Professor Nagendra, and we're happy to answer any questions you may have. Thank you. Yeah, sure.
Okay, folks, I think some of you might have wanted to go to the math session also. So I know that there was a clash and we didn't expect all of you to come here. So what we've done is we've told the math professor to hold on. We'll start the math session here after this gets over. Maybe at 12:45. So you can stay.
So we're happy to take questions.
Yes, please. I just want to know, you were talking about minors, right? So how much percentage from triply taking other
I'm going to give you that.
minors in computer science and so, or core minors taking, how much percentage yearly?
Sir, it will be a small, see, we have a batch of 155 students in electrical every year, about 155. Out of that, maybe some small percentage, I would say less than 20% would be opting for a minor. See, minor means that you have to do a certain number of courses in the other area, and not all departments are minors, some of them have it. And it has to be a designated set of courses, let's say 4 courses or so. But a substantial number, I mean, maybe 20 or so percentage will get minors. And for electrical engineering students, common ones may be computer science, mathematics, physics. Okay. Yeah. So, so these things, right? What happens is in the first year you take core courses, this is for students. And by second semester, in fact, my advice is also, you start identifying your interest. And after that, you decide whether you want to go and take a minor or do other things, do multiple undergraduate research projects within the department or outside the department and so on. Okay. Now, we have also a longer BTech project that is optional, so some students opt to do that. So whether they take a minor or not is really up to their interest. That is, whether they want to spend so much time taking courses from a single department, or maybe take 4 courses from 4 different departments to get a flavor of what's going on.
So the flexibility is there.
Yeah.
They can choose.
Quick question.
Yeah.
Two things, right? When you showed quantitative finance, just wondering how electrical engineering is really helping them in quantitative finance.
So this-
One part. Second is you said about software, right? Now, how much of it is application software versus
No, that firstly, if you actually the placement statistics are online, you can access them, and you can see that in electrical engineering is one of the fields where core jobs are larger in number. There are actually many core jobs. Largely, I would say in integrated circuit design and other circuit design related fields, hardware and so on, and there is also software. Your earlier question was about quantitative finance. See, quantitative finance, to my understanding, it uses knowledge of mathematics and maybe some coding and so on. That our students will be proficient with after doing our courses here. So that's how they are able to use their skill set there. Okay.
We have a very large group working in communications, and they do a lot of coding. There's a lot of coding and
Yeah.
algorithms that you need. So that same skill set can be used in other fields.
but those are not, low-level programming.
No. And they're also very high paying as well. Yeah.
No. Are they doing embedded systems or?
No, there are embedded systems, I would put it in the core area. Yeah, so there are people who do embedded systems also, and then higher levels of integrated circuit design, digital, and so on. So, yeah. I think there was somebody asking a question here.
Electrical engineering includes
Yeah, actually that's what I should say. So outside you hear of electronics and electrical, electronics and communication, instrumentation, maybe nowadays robotics, mechatronics, this thing, that thing and so on. We don't have the mechanical part of it, but all of it, communications, electronics, semiconductors, instrumentation, everything is here in under a single umbrella. She showed a list of 6 subfields. In fact, in many cases, each of those will be a department. So both by research funding and by the number of faculty, our department is the largest one in IIT Madras. We have 73 faculty, and they cover all these areas.
These devices include the medical devices?
So we have a group which says instrumentation. We have actually a very large organization in Research Park called Healthcare Technology Incubation Center that falls in the instrumentation group, and they are the ones who are involved with medical instrumentation.
But that comes under electrical?
Yeah, it is in our department. Now we also see many are cross-disciplinary. We have a recently formed department called Medical Sciences and Technology. So some of them also would be involved in some things. But the Healthcare Technologies Incubation Center, the driving force is one of the faculty in our department.
Just curious, madam, you gave the example of a cell phone, which is great, right? Are we doing anything here to make it an indigenous, to build an indigenous?
Yeah.
There's a lot of work going on in the circuit design as well as in the communications. But the instrument itself, I don't think we have anyone. But in the subunits of it, yes.
So the 5G, say up to 4G, basically the technology was essentially determined by foreigners and we followed it. 5G was the first time we got on board at the sort of entry level. And the 5G testbed, the system level testbed, indigenous testbed was set up here, and that was by one of our faculty colleagues. Now the instrument itself, of course, is a different thing. That needs mass manufacturing and so on. That will not be done in a university. But the testbed was done, and pieces of the integrated circuits will be done. And she showed the display. That is also for, because all of us are surrounded by displays, all of them are imported. And the goal of the display center is to not only make prototypes, but to establish a company that will mass manufacture them.
Sorry, one more last question.
Yeah, go ahead. Yeah, so there are different, again, when you say quantum, there are different things. One is the theoretical part where you assume that a quantum computer exists and you solve what algorithms you can on that one. So that is going on in our department as well as in physics and some others. And there is one particular thing called quantum key distribution for security. And that is, part of it is going on in our department. So there are actually, and the photonic components that are required for these systems that are built by, there is a center called Center for Photonic ICs in our department. That's what is in. DRDO? Well, I don't know about DRDO, but yeah, the encryption key work is, and the random number generator and so on is done by our department. Yeah. Yes, you had another question?
Yeah, one last thing about, obviously one of the core areas of electrical engineering is power distribution and
Right.
all that stuff. Right? I mean, is there less focus on that?
No, actually,
Don't hear that at all.
no. This, we have a very strong power electronics group in particular, power electronics and drives, and also power systems. Maybe when you said distribution, perhaps you meant power systems.
I meant the electricity power distribution.
Yeah, that,
Distribution, high voltage distribution.
correct. So that's what, that falls under this power systems, I think. So we have 2 faculty working in that. And then we also have a very strong group in power electronics and drives. Yeah, lots. Actually, we are the leading academic group in India on integrated circuit design. I am from the ICS group. Yeah. We have actually the largest selection of courses, both basic and advanced electives. And our video lectures are online and they are used by everybody.
The AIML is integrated with all engineering branches, as you know. So the electrical engineering students are supposed to learn AIML and apply in the projects. They have to integrate.
If it is relevant, like for instance, our image processing group, they use a lot of ML in their work, and they also offer courses related to that. There are also general ML theory courses as well.
We have
The project they
courses.
do in the final year, they always do kind of
The
ML related.
project is
No, not,
optional.
yeah,
If the
but
student wants to do a project, it can do, and it depends on the topic.
so not every project involves ML, if that's what you're asking. There are projects which don't involve ML at all. That is entirely possible.
But now it is in general, every part of, projects.
No, that's not quite true. No, that's not quite true. Actually, there are lots of projects which have nothing to do with ML, and there are projects which have a lot of strong ML component. Okay.
So our department is
Yeah,
very
maybe-
strong in software and hardware, both. So for some projects you need both, for some you don't need.
See, electrical engineering that way, it has, it's some sort of, there is a lot of core stuff that you have to learn, but it is adjoining, some parts of it are adjacent to CS, some parts of it are adjacent to physics, some others are adjacent to material science. So if you become strong in electrical engineering, it's very easy to even branch out into those areas. I think we take a question from a student for a change. Yeah.
Heard that electrical subject is the most demanding course.
Demanding in what way? Just like, this Olympics are the most demanding games, right? Not that way.
I
So what
asked a different question, where did you hear that from?
No, see, you have to learn, yeah, I will, let me just answer. Huh?
I heard it here yesterday
Ah.
from one of your faculty.
Okay. So let me answer it this way. So firstly, to gain expertise in something, it takes a certain amount of effort, and it's in any area, right? And like if you have a set of high quality faculty, they also expect effort from students. At the same time, I have to tell you that if you look at the departments in IIT Madras, electrical engineering is the one to which most alumni have returned from all levels. BTechs, I'm a BTech from here, she is a PhD from here, and also from MTech, MS, and so on. I mean, we would not have come back if we thought that the department is no good, right? So, demanding is fine. I would say actually other departments are not less demanding in some way, right? If you go to mechanical engineering and you want to learn mechanical engineering well, you have to put a certain number of effort. You may have heard of the 10,000 hour rule, which says that to gain expertise in some area, you have to work for concentrated work for 10,000 hours. So yes, but I mean, we have students who do very well in that, and then they also go on to do very well. The second thing is, see, your BTech lasts 4 years, your career lasts maybe 40 years or so, 35 to 40 years. So to be on top of that, I mean, you have to master something for which there is high barrier to entry. So that means that you have to put in a corresponding effort. Okay. So that is there is the effort, and there is definitely a corresponding reward. Yeah.
I'll also say, because we have such excellent faculty, classes can be a pleasure. So yes, you have to work, but you're not sitting in a boring class.
There's general perception that electrical is a more difficult branch.
No, that's what he asked. And I would say any subject, if you want to learn, you have to put in a certain amount of effort. Now, we have all these faculty and we have all these courses. Now, when you're taking them, you have to put a certain amount of effort to get there.
Compared to other branches, I think you put more effort on electrical. That's what
No, but I mean, to what end, right? I mean, so you put this effort and you get something.
Electrical, electronics, you got multiple
Oh, that's, by the way, those names may not be familiar to everybody, but in every area there will be sub-branches. If you go to mechanical, there will be thermodynamics, there will be structures, there will be something else and so on. So that is not,
Your two cores, you're mixing the electrical as a core and electronics,
So
communication.
actually, research today is very interdisciplinary.
Yeah,
You
yeah.
take any topic that any faculty member is working on, and you can hardly say that it's focused in one. We are more aware of electrical and electronics, but that does not mean that those are the only two areas within our department. In fact, we had a visitor some years ago. He said, if you're in the electrical engineering department as a faculty member, that means you're an electrical engineer. Doesn't matter what you're doing. And I think that it partly be true in every department.
so yeah, we have faculty who are practically applied mathematicians,
Yeah.
and we have faculty who are almost like computer scientists. We have faculty who are almost material scientists and so on. So there is a broad variety.
So how much collaboration with engineering physics department and electrical?
So engineering physics is a course, it's not a department, I mean, it's a program. So that program is a mix of physics and electrical engineering. In fact, almost all our core courses have EE and EP students together. So in fact, I would say EP has more electrical engineering probably than physics. And a lot of them also do projects with us. Some of them, of course, also do it with in physics. Yeah.
So
Again, they have a choice.
Yeah.
we have a choice.
Yeah.
The reason being that we are
Yeah.
more in the engineering physics department.
Yeah.
Inclined towards it.
So some of that finally you have to decide based on the interest also. Like engineering physics student will take more physics courses than us, more mandatory physics courses than our students, right?
Okay, but they also have a flexibility to take courses if they find electrical engineering
Yeah,
more
absolutely.
interesting maybe.
Yeah.
So as he said, a lot of the core courses anyway they're taking with us.
Okay, okay.
See, the core courses there are physics core courses and electrical core courses. I would say except for two of our core courses, maybe control engineering and instrumentation or something, all other core courses EP students also take. Now, electives, of course, anybody can take any elective. I mean, provided they have the prerequisite for it. And they can do projects here. EP students can convert to EP, that physics dual degree or electrical dual degree also. So,
So it is called the same department, suppose as you said that EP student can do, suppose at the end of the fifth semester, they have a possibility to convert into the dual degree.
Right.
So if they convert into EE dual degree,
Right.
that is considered to be in the same department or it is?
So they'll get an EP.
IDDP?
No, it's not called IDDP. They'll get an EP BTech and an EE MTech.
Okay.
Yeah.
EM.
Yeah, I think she had a question. She was waiting. Sorry. Yeah.
Yeah, I mean, amongst the IITs, right, in
Yeah.
India, how is the research funding for IIT Madras? So where would you think the IIT Madras will scale amongst?
So if you look at like various reports, our strong point is interaction with the industry. Okay, so we were the first IIT to have a research park of our own that is right next to us. I don't know if you have a chance to go around, you can go that way and see. So an incubation ecosystem is very strong. Okay, so research funding itself, I mean, it doesn't make sense to compare the total funding because the number of faculty in different institutions may be different. But we are not short of funds for sure. That is, I think the level of funding is about the same. That is, our level of funding very roughly is a little more than 1,000 crores per year. If you look at IIT Bombay or IIT Kanpur, which are of comparable size, yeah, now it has become 1,300 crores. Okay, so that's the project funding. I think the government funding is yeah. So the MOE funding. So by the way, we get funding from Ministry of Education. We get lots of other funding from projects. But anyway, roughly speaking, the 5 old IITs are of the same size, same level of funding, same everything. So there is no discrimination in that way.
It will be of the same level, right?
The funding will be of the same level. Funding will not be. But we get a lot more funding from private industry than other IITs. That's our strong point, actually.
So you can write proposals to either ministries and
Yeah.
get funding from ministries. You can also collaborate or consult for
Yeah.
companies and you get funding from there as well.
But one thing I have to say, this also does not have too much bearing on the BTech part of the education, right? I mean, the general state of the labs and so on, it will have influence on, but the BTech program itself, not so much directly. You have-
The CEM program, again, similar question to the DD. Do we get the best of
Which program?
the CEM?
This CEM program faculty will be there at 3 o'clock.
Yeah.
Do you think maybe we can...
What is CEM?
Computational engineering and
Ah,
mechanics.
okay, that is in the applied mechanics department. Applied mechanics department. So that's from a different department. We are not. Not a lot. I think the basics you do, and maybe at the system level, perhaps robotics and related stuff. But and then some computational stuff.
But those students will have, they will also have the same, the structure of curriculum is the same. So they also have these unallotted credits. They can take courses in another department if they so wish.
Yeah.
I'm adding to your question. The companies that come here for core electrical, do they take engineering to these students?
Oh yeah, very much. Yeah. See, actually, at the time of graduation, I mean, from my own experience, there's hardly any difference between the EP students and EE students in any way, right?
If you were to look at IIT Madras, electrical specific to and peg yourself against, say, the best in the world, where would this particular one?
Right. So it depends on the area. So, like if you look at QS rankings, we are probably between 50 and 100 or so. But again, those rankings, yeah, you have to put whatever trust you want in them. So, now within India, we would also be probably the second in the among the IITs and so on. So,
Connecting to that is with all this AI disruption being thrown at all tech.
right.
How are you prepared to handle this, this huge mammoth?
Correct. So one is of course using AI for our own work. We do that, and then like for instance, slowly the nature of assignments we give are changing based on the availability of AI. So that will. So one is of course research into AI itself that people are doing. We have people working on ML algorithms and then theoretical AI, machine learning and so on. And the other part is using AI for whatever it is that you want to do. That all of us are doing in some way, and I think as I see going forward, our assignments also will have more of these components and maybe less of other things.
But more because there is this general perception that India is not yet there on the AI space, not yet fully equipped to handle that disruption that will come. So considering that background.
Correct. So again, if you are talking about using AI tools for let's say circuit design or other things, I think that we can equip ourselves with. If you're talking about LLM development within India, ML models within India, that we are behind. Okay, but our department is not directly involved with that either. I think there was. No, I mean there is a very large choice, and also we keep signing MOUs with new institutes when the opportunities arise. So many students do go on exchange, and as I have seen, they go to lots of places, Singapore, Europe, US, many places. So,
But it's important if you want to do that as students, that you attend classes, because we do have some flexibility in attendance, but it matters for these things. And you need to have finished your core courses,
yeah.
right? You won't have these opportunities if you're pending core courses right in the last year. So if you want to have those opportunities, you need to work hard from day one.
No,
Yeah, but
I
you
mean,
won't be allowed to go if, say, for some reason you failed a course and it's pending till the last year, then you won't even be allowed to go. So if you want to go, you must make sure that you keep on track and finish by your 5th, 6th semester.
Let's take a 2-minute break. The math session, which was supposed to start at 12, they pushed it to 12:45 in the adjacent hall. So I know that some of you have individually come and told us that you're interested in that. So those of you who are, would you like to go there? We'll continue the session here for some more time. If there are 2 people in your family, one wants to stay here, one wants to go there, that's also. So we'll just take a 2-minute break so that Sanskrit can go there. We expect
Remove the links to the video.
You want to ask something? Yeah.
So I'm interested in biomedical engineering.
Okay.
And I actually I talked to the email they
No, this one I didn't.